What's up, guys? Welcome to topic 1, attributes of quadratics. All right, so what is a quadratic function? Quadratic, let's just look at this. So here is when we say the parent function, we're asking what's the basic function, the one that we start with. This is the parent function. Let me do this, 3.5. It's y equals, well, actually, you'll see it two ways. You'll see, we'll start with y equals x squared, or you'll also see it as f of x equals x squared. All right, that's what we call the parent function. So basically everything builds off of this, right? Now, if this is the parent function, let's go ahead and figure out what this graph looks like and what a table will look like. What does it do to the table? So if this is the equation, let's fill in this table. And we know how to fill in this table because if I'm given my x values, all I have to do is plug them in. If I'm given my x values, I'll have to plug them into my equation, and then that will give me my y values, right? So I'm going to get my calculator real quick. Let's see, I got a bunch of things up. Where is my calculadora? Bring this up, bam, and bring it up here, bam. Ooh, fancy schmancy. All right, so we got that here. So let's just think about this. So it's x squared. So what would this look like right here if I plug this in? This would be -3 squared. But we know -3 squared is -3 times -3, which is 9, right? -2 squared, this would be, if I replace x with this, -2 times -2 is 4. -1 squared, remember this is 1. Okay, this is just going to be 0. 1, this is going to be 4, and this is going to be 9. I don't even need my calculator, sorry. All right, bam. So we got my table out. Now let's look at the graph. Now, for me to look at my graph, all I need to do is take these points, and graph them on this little graph right here. So -3, 9. -3, 9. Let's say it's going to go right here. Bam. -2, 4. So we have -2, 4 is another point. And -1, 1. And we have here. And then we have 1, 1. And then we have, what is this, 2, 4. And we have 3, 9. Okay, so this is it's just some points of this graph, and then of course this graph curves. It's not at an angle, but it curves, right? It goes like this. Whoa, that was ugly. But that is what the graph looks like. This is what we call a parabola. So somewhere, right, parabola. It's called a parabola. All right, now what are some characteristics about this parabola or this quadratic function? We have some things that we have to remember when we're going about doing this. So 1, domain. Remember, domain and range. It was a long time when we did domain and range, remember? So domain, what I'm talking about is all possible, right, x values. That's what I'm talking about. What's all possible x values, and this is all y values, right? What's my all possible y values? So let's go ahead and look at this real quick. X values. So can I draw a line here and say this is the farthest side, this is the farthest it goes to the left? No, right? Because this line, this arrow indicates that it's going to keep going up, right? Even though I don't have it drawn on here, it's going to keep going up, 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 just this way like that. So I can't just say this is where it stops to the left. It doesn't. It keeps going up. So it goes forever to the left and forever to the right. So which means it goes to -infinity to +infinity. And when we go from -infinity to +infinity, if you remember, that is considered all real numbers, right? All real numbers. Or this symbol right here. That are all real numbers. This will always be the case for quadratic functions. Your domain will always be all real numbers. Now, what is my range? Remember, range is how high up and how high low. That's my range. So let's look at this real quick. So if I'm thinking about, this is the very bottom of my quadratic, right? It doesn't go any lower than that. So it actually does stop, but it doesn't have a max. It doesn't have a height, the highest point. I can't just draw a line here and say, yep, this is where this is the top of it and it stops here. No, these arrows indicate the same thing. It's going to keep going up. So it goes forever up, but it stops right here. What is this y value? This is 0, and it's go all the way up to +infinity, right? So 0 to +infinity. So that's how we would write that. So this is what we're writing as a compound inequality, or let's just write like this. See, all my y values must be greater than or equal to 0. Greater than or equal to 0. All right. Okay, so that's how our range is greater than or equal to 0. And then what else do we have here? We have this thing called, let me go and highlight some stuff real quick. We have domain, we have range, we have a vertex. Now our vertex is basically the highest or lowest point. So we have either the highest or lowest point. So let's think about this real quick. If I am following this parabola, going down, going down, going down, this right here is going to be the lowest point, okay? Sometimes parabolas will be reflected like this, and then this would be the highest point. So it just depends on what it looks like. But right now, this goes this way, and so this is the lowest point. So then the lowest point is your vertex. So if I'm trying to look at what my vertex is, it's whatever this point is right here, and this point right here is the origin, so it's 0, 0. That's the vertex at this for this one right here. So the vertex is 0, 0. And then it wants to know, is this a maximum or a minimum? So let's think about this real quick. Is this the lowest point on this graph, or is this the highest point? It's the lowest point, right? Because this graph's going to go forever up. So it goes forever up this direction and forever up in that direction. And so this right here is the lowest point, right? So this is what we call a minimum. It's called a minimum because it's the lowest point. Now, if it was, let's say if it was reflected like this, right? And then this is the vertex. This is called a maximum because this is the highest point that it'll ever reach, and then it goes back down, okay? So that's a minimum. And then we have this thing called concavity. This is super easy. It's basically saying, is this graph open concave up or concave down? Now, if it's open up like this where it is here, right? This is opening upwards, then this is concave up. Now, if it'd be open down like this would be concave down, and that's super easy to remember. So right now, concavity is concave up. Last but not least is line of symmetry. So line of symmetry basically is, it's an equation, and it's basically, if I wanted to cut this graph right here in half, where basically this side was exactly this side here, where would I have to cut it? Well, you'd have to cut it at the vertex, right? You'd go straight down the vertex, and this right here is your line of symmetry. Now, this right here is an equation. It's not just a number. So what equation is this? Now, if you guys remember, we have this thing called Hoy, and then we have Vux, right? So is this a Hoy or a Vux? It's not a horizontal line, so it can't be a Hoy. It's a Vux, right? So Vux says vertical line, undefined slope, and your equation is x equals whatever that x value is. In this case, the x value that goes through here is 0. So your line of symmetry is x equals 0. And I'll say this. So say, let me just put a note, right? Line of symmetry, or also known as axis of symmetry, axis of SYM slash line of SYM, right? So that's what it's also known as. But what's the note? The note is that, what do I want to say? So it will always be the x value of the vertex. Will always be the x value of the vertex. Bam. And that's it. So we're going to do a few more examples so you guys get used to this, okay? So let's go ahead and look at this real quick. So here we go. Here's this parabola. All right, here's this parabola. Now this equation looks different than our parent function, right? Our parent function is let me write this. Our parent function is y equals x squared. That's the basic one. Now if I was to do y equals x squared, right, so it'd be something like this. 1, 1, 2, 4. Oops. So there you go like this. This is our parent function right here, something like that. Now, when we start changing numbers and adding and subtracting stuff like we're doing here, then it starts to move. It's called transformation. So let's go ahead and look at this real quick. This is parent function. So then vertex. Remember, vertex is highest or lowest point. So we figure out, here's my vertex, right? So what point is that actually? So this point right here is, what is that? 2, -2. 2, -2. That's my vertex. 2 comma negative 2, bam. My line of symmetry is like if I want to cut this bad boy right in half, where would I draw that line? That line, let's put some red. That line would be right here. Right, this is my line of symmetry. Now my line of symmetry is an equation, so what would this equation be? Remember, this is a Vux, V-U-X, so vertical line, undefined slope, so your equation is x equals whatever that x value crosses. What x value is that? It's 2, so your line of symmetry is x equals 2. All right, cool. Now what do we do? Does this have a maximum or a minimum? So let's think about this. I'm gonna follow my graph and see, does this have the highest point or a lowest point? Keep going, it reaches its lowest point and then it goes back up. Since this stops here and it goes back up, this is a minimum, this has a minimum. So it's a minimum. And we gotta figure out, is it concave up or concave down? In this case, since it opens up, it is concave up. So concave up. Domain and range. All right, here's the easy part. Domain is always going to be the same. Domain will always be the same, so it's always going to be all real numbers. So I'm doing this little symbol. It's like an R with an extra line, all real numbers. Because if I think about this, it's going to go forever to the left and forever to the right. You won't stop. All right, so range, let's think about this. What's my highest value and what's my lowest value? So if I was to think about my range, we know it's going to go forever up, right? That's what these arrows indicate. But what's the lowest value? Where does it stop at? What is this y value here? This y value is negative 2, right? So if I was to do that range the way I taught you guys originally, let me erase this real quick, right? So it goes from negative 2 to, it goes up, all the way to what? Positive infinity. And range is always my y values. So you could write it here's one way I taught you guys, right? It was like, So it's negative 2, and it has to be less than or equal to y less than positive infinity. Or if you wanted just to write this first part, I'll highlight it. It's the same answer, domain and range, if you just wanted to write this first part. Negative 2 less than y, or y has to be greater than or equal to negative 2. Same thing. That's the range. And then roots. Here's something that we're introducing, roots. You guys know them as another name. Roots are also known as zeros, right? Zeros, but they're also known as x-intercepts. So if I'm asking what are your roots, I'm asking what are your x-intercepts. I'm asking what are your zeros, I'm asking for your x-intercepts. So let's go ahead and look at here, and your x-intercepts are going to be points. So if I'm following this graph to see how many times does it cross my x-axis. So I'm going this way here. Oops. I'm going down here, down. Bam, here's one x-intercept, and then I keep going, I go back up, and I cross it again. So I have two x-intercepts, or zeros. So let's write those as points. So here's one x-intercept, and here's another one. Those are my x-intercepts. So let's go ahead and write those as points. The first one, let's just say it's in the half. Like if this is half, right, 0.5, what is that as a point? It's going to be 0.5 comma 0. One of them will be 0.5 comma 0. And what will the next one be? Let's say this is 3.5. So 3.5 comma 0 will be the next one. So 3.5 comma 0. All right. So I know this is a lot of new information, but that is quadratic functions. I'll do one more example, and then you guys can jump to the back and try to work this out yourself, okay? Pretty self-explanatory. So let's do one more example. So here we go. So I'm looking at this one, and then again, this one is y equals x squared is my parent function, so it'd go up like 2, ugly. So 1, 1, 2, 4, bam, bam. 1, 1, 2, 4, bam, bam. Sorry. Joe, yo. Yeah. Oh man, I wasted a bunch of time. All right, sorry guys. So 1, 1, 2, 4. Now, what I need to do next is I need to go ahead and figure out all my stuff. So that would be my parent function. You don't have to draw this. I'm just showing you what it would look like compared to your parent function. All right, so first we need to find our vertex. Remember, vertex is either the highest or a lowest point. This is my vertex right here. I'm actually going to delete this. It's wasting space. All right, vertex is that. What is that as a point? This point is -2, -2, 6. Vertex is -2, 6. Bam. All right, line of symmetry. Our line of symmetry always crosses through our vertex. Here's our line of symmetry, just right here. Bam, bam, bam. Remember, our line of symmetry is an equation. So what is this? X value that it crosses, it's going to be x equals -2. Bam. All right, is this a maximum or a minimum? Well, if we're looking at this, this is the highest point on the graph, and then it goes back down, so this must be its maximum point. So it's going to be a maximum. Now, is this concave up or concave down? Well, these two arrows are opening downwards, so that means this is concave down. Right, domain, easiest thing, right? Domain is always going to be all real numbers. And then range is the one we have to actually think about. So we have to say how high does this go and how low does this graph go. So if I'm thinking about it, we know that it starts right here, like this is the highest point, and it's going to go all the way down. So what am I in between? This one up top, this is a +6 value, and then it goes down to -infinity. So that means your y values must be equal to or less than 6, right? Equal to or less than 6. So if I'm writing this, I'm just going to write it without the infinity symbol this time. So my y values must be less than or equal to 6 because they need to go all the way down. Now, in this case, they're asking for our zeros, but we know that zeros means just what are our x-intercepts. So let's go ahead and highlight those. Here's one, right? 0. Here's another 0. Oops. All right, let's just write those as points, and we are done. Done. So this, let's say the one on the left. The one on the left, what point is this? So this is going to be, I'll say -4.5 maybe. -4.5, comma 0. And what else do we have? Say 0.5 maybe, and 0. Bam. All right, so that is an introduction to quadratics. I want you guys to try to do your best and fill this out yourself. I will do one more thing, actually. You all just fill out this top area right here. Just fill out that top area, and then right here, what they want you guys to fill out is your C value. What is your C value, or your C value that goes here and here, here? Remember, standard form is this right here, ax squared plus bx, plus c. So when they say, what is your a value, they're asking, what is that number in front of your x squared? What's your b value? What's the number in front of your x? And what's your c value? What's that last one? If it doesn't have a c, what is your c if it's gone? What do we normally call it? And then line of symmetry, there's another way to find it. Negative b over 2, negative b over 2a. Negative b over 2a. And then, so, oh, actually, let's go over the last few problems, and then we'll be done. I know. All right, so how do we find the axis of symmetry if we're not even looking at a graph, right? Because remember, we were easily able to find the axis of symmetry at these because we can actually see the graph, and it's like, oh, the line, I can draw a line here, so here's my equation. So how do we do that if we're not given a picture? One, you can actually plug in your calculator and look at the picture, or you can use this formula. This formula says negative b over 2a. So first, let's figure out, this is my a, this is my b, and this is my c. So if it's negative b over 2a, I just plug it in. So now I have a negative 18 over 2 times a, which is a negative 3, and we just solve it. Excuse me. It's a negative 18 over a negative 6. What is a negative divided by negative? That's a positive. And what is 18 divided by 6? That's going to be 3. So your axis of symmetry is, remember, it's an equation. It's actually x equals 3. Bam. Easy peasy. All right, so let's do one more. So low power mode. All right, so let's do this one. So if it's negative b over 2a, What is my negative b? Whoa, 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 whoa. There is not a b value here. How do I know that? Because let's think about this real quick. Remember, it's always ax squared plus bx plus c. Now, if there's not a b value here, it's actually there, but it's just at 0, and it's pointless to write. So if I was to actually write this, it'd be negative 0 over 2 times 1. But anytime you divide anything into 0, right? Anytime you divide anything into 0, if you plug it in, it's just going to be 0. So now what does that mean? It means your axis of symmetry is just x equals 0. That's what it is, right? So it goes straight through, it looks like this right here. This is x equals 0. This is your axis of symmetry right here. When it's x equals 0, it goes right down this line. All right, last one. Again, negative b over 2a. So negative b over 2a. Let's go and fill it in. Negative, so we have a negative 20 in this case, right? Because that's my b value right here. So it's a negative. That was already in the formula. And then we have a negative 20 over 2a, which is 5. All right, let's go and simplify. We know up top, a negative times a negative 20, that is just going to be 20. And then 2 times 5 is 10. What does this simplify to? 20 over 10 is 2. Remember, axis of symmetry is an equation, so it's x equals 2. Bam, bam. Yes, sir. All done. All right. So go ahead and take your time to fill out this top part right here, and then you guys can proceed to your homework. Have a great day.